just to have some company out there, be identifying with, this is something that could be useful for me.
Yeah, I didn't finish the story about the types of companies we worked with. I mean, we had contacts with companies in the past, many of them, some big companies and some smaller companies. There were already AI companies we spoke with 2 years ago, before the LLM hype and everything. There was a company doing speech synthesis, text-to-speech. Another one doing battery inspection with computer vision. And they used successfully EuroHPC with our help. But there were many companies as well doing the traditional HPC domains like computational fluid dynamics and electronic structure calculations, molecular dynamics, biomolecules. Yeah. But it's really been an acceleration of contacts with AI companies lately, and I think that's a good thing. I mean, that's certainly the signal we get from above. Find your AI SMEs nationally. I mean, message we hear, and it's directed to all the national competence centers in this network that, focus on AI.
In my very subjective view as well, I think that Europe in general, at least in the last 10, 15 years, has had far too little focus on AI versus like US and China, of course, put much more effort into it. Do you think that's something they are trying to remedy now a bit by actually putting more focus on AI, or would you say it's similar to what it has been in the last 10 years in terms of investment in like AI related?
Well, my impression is that it's accelerating. I mean, it's really a higher level of ambition now than it ever was before. Exemplified by the AI factories, and making the EuroHPC machines, currently existing ones and future ones as well, more usable for AI companies. Another example of this is that, when you apply for EuroHPC, you can choose different tiers, smaller tiers, which are really easy to get. You just write a small technical application, evaluated by one HPC expert on a technical basis. And then there are bigger tiers, going up to extreme access. But recently, EuroHPC introduced the AI and data intensive access for
once again
AI and data intensive tier to EuroHPC.
Okay. To make basically for this use cases, find a, try to be as smooth as possible for these use cases to.
Yeah, I mean, it doesn't affect really how usable the EuroHPC systems are themselves. It's about
the administration.
Administration, how you apply and so on. I mean, and the whole atmosphere in Europe, in EuroHPC, and the Commission is to facilitate as much as possible AI companies to get to accelerate. I mean, to grow as quickly as possible. There's really a lot of focus on SMEs and AI.
And you have given a cliffhanger now a couple of times here. What is really the compute? What does it continue?
Continue. Well, I don't know who coined the term sometime in the past, but it's adopted by our brilliant colleague and friend at RISE, Johan Christiansson, who has this vision for the future. So he comes from the cloud. I mean, we're comparing cloud to HPC all the time now, right? And it's a very pertinent, very relevant comparison to do. And he comes from a cloud background and realized the importance of. So he sees the complications with cloud. You have hundreds of different services you can find from these different cloud providers. And then he, through research at RISE, there's lots of research on edge computing. And with us, ENCCS, when we came into RISE, there's again a focus on HPC. And the this smorgasbord is just growing, right? And they're all distinct. They all have their own distinct qualities and complications. We need something to glue it all together. And the future vision with the compute continuum is that compute should be like a commodity, like electricity. You plug something in the wall, you get electricity. You should be able to do the same with compute.
Amazing vision to have.
Oh yeah. And as a step in that direction, he's been developing single-handedly a very cool framework called Colony OS. It's a meta operating system, which is Colony OS.
Colony, okay.
OS as an operating system. I mean, it's more computer science than I care to know, but there's lots of ingenuity in this platform. and it's meant to abstract away all the complexity of the backends. I mean, you can keep data in cloud S3 or something. You can run certain lightweight things on your own computer or your on-prem whatever cluster. You might have edge nodes, and then maybe you have a part of your workflow is compute heavy, R&D related, whatever. It needs to run on HPC. And this framework can orchestrate and automate a lot of things. And this is not an old idea. There are not a new idea. There are many projects that have been started, and not many have actually reached anything. But this is production ready. This is already in production in Sweden, yeah. And it's something we're looking for potential interested parties in trying out. I mean, in actual production.
Because in some way, if you see like the top scale kind of compute project, take LLMs or whatnot, they seems to be, super optimizing a very more and more specific compute projects. Like, for large LLMs, you need to have a super high bandwidth. It's not really flop limited anymore. It can be more like the bandwidth with limitation, because they need to send the gradients around to such an extent for these large models that it's actually limited by bandwidth rather than compute potentially. And they seem to be optimizing everything and making it work only for transformer based and only for this very specific use case. And this one is going in the other direction, which is, I think, is interesting. I think both should be, interesting areas of research. But would you agree with it that some kind of movement is just saying, how can we just make this work for this very, very specific use case?
Yeah, I mean, it's all moving into more heterogeneity, more variability of different platforms, different architectures, optimized for different purposes.